Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, August 19th. Looking at significant wave heights for the South Pacific Ocean, we see a calm pattern again in control of the South Pacific. Virtually no storm activity or gale activity is anywhere in the Hawaii or California swell window, and the expectation is that pattern is not going to change anytime soon. Let's get into the details. As usual, we'll start our tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when those gales form, help direct their track. We're looking for a trough or some sort of a dip in the jet stream. Actually, this is the southern branch of the jet stream, it'd be a pattern pushing to the north, and literally in the southern branch here, you don't see anything like that. The northern branch, very strong, but it isn't doing anything either. Normally it doesn't. It's not really conducive to helping support gale formation. It's this southern branch here. Right now it's down running around 63 south, and the ice line, the Antarctic ice line's right about there, and it's incredibly weak. There's virtually no energy. All the energy is being sucked up into the northern branch of the jet here and just not doing anything at all. So for right now, a calm pattern is in play. And as we roll this out, you can just sort of see, yes, we get some wind energy starting to build into the southern branch, but again, it's way far to the south, down around 63 south. And this really looks like the jet stream still believes that La Nina is in control, though we know that is not the case. But, the atmosphere takes quite a while to move from one pattern to the other, and it was only a couple of, 2 to 3 months ago that we were in a good solid La Nina pattern. So clearly the upper atmosphere has not responded to what's going on down in the ocean or in lower levels of the atmosphere just yet. Anyway, we're out at Thursday already. The jet stream's still very zonal, running around on the 62, 63 south latitude line. No troughs, that is, no dips pushing up towards the equator in the jet stream. And then, if anything, we get a bit of a ridge pushing south into Friday. That only makes the problem worse. Sort of, maybe, if you stretch it, a trough is to try and develop in the far southwest Pacific a week out on early Sunday, the 26th. There you go. That actually looks like a semi-real trough, but we're out at nearly the 100. There, in fact, that's a real trough there with 120 knot winds pushing up into it, but that's at the 180-hour mark. Never believable. Don't believe any of this, but this is the first sign of anything that looks like a trough in the better part of 2 weeks, so we'll grab on to any little hope we can get. All right, let's go take a look down at the surface level charts. And here we are, surface level pressure, surface level winds, and as expected, when you have that sort of split jet stream flow, you get high pressure in between. That's exactly what we're seeing. Virtually no storms of any interest in the California-Hawaii swell window, which roughly runs from about 155 east over here to about 120 or even 110 west. Just nothing. A little patch of 30-knot winds, but they're all pushed south towards Antarctica. We'll just sort of roll this out, and you can see, okay, yeah, you get a little gale here with 35-knot winds, but that's outside the California swell window. Then you get this cutoff gale up here on Tuesday in the far northern latitudes, and it actually has winds pushing up to the north, but watch its motion here. 45, almost 50-knot winds, but it's falling directly south. So those winds have a real hard time getting traction on the ocean surface, pushing anything to the north. What you really want is south winds with the gale itself lifting to the north. That even a small system like that can get you some decent surf, like the swell that was hitting Friday, Saturday in California. That was a tiny little system way to the south, but it was pushing due north. This system's doing the exact opposite, pushing due south, so we're basically writing it off and saying nothing's going to come from that, at least nothing of any real interest. And here we are, we're into Thursday, Friday. Here's a gale way down south of New Zealand, but over Antarctic ice. That's no good. No traction, and it fades out. Now a little fetch come Saturday south of New Zealand. Tiny little area, 45-knot winds, racing off to the east, building a little bit. Maybe there's some hope here, but then 55-knot winds, barely clear Antarctic ice on Sunday, and then fading. Another fetch developing. We know there's a trough building in this area, so it would make sense that something might happen here. So there is some hope about a week out also here on the surface level pressure charts. So that brings us to the significant wave height charts, okay? The way this model works is it takes winds from the GFS model that we were just looking at, imparts them, and runs the analytics to determine what effect those winds will have on the ocean's surface. And, of course, right now we know there's no winds of interest, so, of course, there's no seas of interest. And here's your ice line up to 60 south at 2 points and not any further south than maybe 65, 64 south. So, we say 63 south's the ice line generally. So we're looking for any seas. We'll even go for 28 feet or higher, and we're not seeing it. Now, here's this little low. We're into Tuesday night, little low, but this guy falls south. Yes, he generates 38-foot seas, maybe 36-foot seas as we get into Wednesday or so, but they're falling south and basically of no interest. We'll see what really happens with that one. Again, we're looking for seas. Okay, 28 foot barely under New Zealand. That's, with 6,500 nautical miles to go. Tahiti might see something from it, but that'd be about it. And it doesn't even push north. Now, here's another one. Come Saturday, we saw that on the charts. 32-foot seas, building to 36 or so, up to 40 feet, aimed due east and almost falling southeast. Probably not anything from that, and there we are, we're done. So, again, whatever it is, this La Nina-like pattern, inactive phase of the MJO, we can't even say that because that's not really the case. Just some strange last-ditch pulse of La Nina appears to be hanging over the South Pacific and just not giving us a whole lot of optimism. So then we go take a look at the North Pacific, and we're going back a little bit in time. Saturday, just a day ago, a little gale was developing here in the northwestern Gulf of Alaska. Built 20-foot seas aimed south. There's Hawaii. You can see one little directional arrow there aimed pretty well at Hawaii. Building up to 22-foot seas aimed right at Hawaii, and then fading from 20-foot seas Sunday morning. And that was pretty much it. Very small system. Now, your eyes, of course, are drawn to multiple tropical systems. These guys over here in the far southwest Pacific, we're going to kind of ignore them for the moment. But this is Hurricane Lane approaching Hawaii. We're going to get into that next. So here's the data for Hurricane Lane right now, 18Z on Sunday. How far is that? Well, these roughly 3, 6, about 700 nautical miles from Hilo, southeast of Hilo, tracking just barely due north of west at 12 knots. Seas 34 feet right here. Clearly some swell is going to be generated for the southeast shore of the Hawaiian Islands. This track is to continue for the next several days, but notice it's at peak speed right now. That's 110 knots. That's roughly, we'll just calculate out here, times 1.15. 126.5 miles per hour winds. That's sustained winds, 126.5. So certainly those winds it's not huge to storm, but getting some traction on the ocean surface, generating swell, radiating towards Hawaii. As you see here, wind speeds slowly to decrease over time. It's about peaked out. Actually, it was, I think yesterday afternoon, it peaked out at about, what was it, about 120 knots, 135 or so miles per hour. On the 22nd here, that is on Wednesday, Lane is to be due south of the Big Island of Hawaii. That's about 250 miles, maybe 225 miles due south of the islands, with winds 85 knots. So hurricane status still, and then passing south of the islands, pretty well south, at least 200 nautical miles for all the islands, and really having no direct impact on the islands. But high pressure is to be north of here. We'll get into that in a second. So here's the GFS model's take on Lane and its track. We'll just sort of run through this. You see, pretty much like what the model said. Now, let's see if this holds. Notice a little bit more of a northward jog than what the official track suggested, and actually bumping up very, we'll call it close to the islands as we get into Thursday, maybe 50 nautical miles south. But notice all the winds dissipating at that time. Dissipating at that time, going this way. and then literally vaporizing as we get into Friday night south of the islands. But let's go back. The one thing we do want to draw your attention to here is, see, high pressure, 1028 millibars to the north, low pressure here. The closer these get together, the tighter the isobars get, the stronger the winds get. So we see, and this is relative for wind swell for the Hawaiian Islands, 15, 20 knot winds. As we get into, we'll even go back to, about here, Monday, late Monday, 15 knot winds building, good for maybe small easterly wind swell. Then as we get into Tuesday night, 20 knot winds out of the east-northeast, building over all the Hawaiian Islands Tuesday night into Wednesday, continuing into Wednesday, and then maybe building 25 knots or more in pockets on some islands as we get into Thursday and Friday. So there's a bit of a difference between the official track GFS. GFS model has lane coming closer to the islands but fading out sooner. The official track has lane holding together more but further south. Best suggestion at this point in time is don't trust the models this far out in the future. Monitor your official NOAA sources for hurricane lane advisories and take it from there. Otherwise, let's take a look at the greater North Pacific Basin and see what's going on. Here's the remnants of our gale in the northwestern Gulf, 18Z Sunday, 18-foot seas still pushing towards Hawaii. Small swell expected into Hawaii. Tuesday, Wednesday, not sure. You can take a look. You know where to look for the data. But swell size, we're talking 3.5 feet at 13 seconds or something like that. Maybe 4.5 foot faces, something like that. So nothing big to worry about. Multiple tropical systems off of southeast of Japan, moving inland, both of them. No obvious clear path for recurvature. And you can see that they're looking for any other signs of some gale developing in the North Pacific, and we don't see it. But we do see at least low pressure and some indication that the transition towards maybe a fall pattern could be starting. Other than that, let's look at wind swell. We've talked about Hawaii, certainly copious wind swell for the islands there, and maybe hurricane swell, mainly for the big island, Hawaii. Relative to California, yes, there is high pressure, 1030 millibars in the Gulf of Alaska, generating a weak gradient, 15-20 knot winds along the North California coast. That's today. Building maybe to 20 knots on Monday for a little bit. That might make for some limited wind swell, but for the most part, lighter winds south of maybe Point Arena or so. And then even that modest fetch dissipates. Strong high pressure, 1032 millibars, locking down the Gulf of Alaska into Wednesday and Thursday. Not quite reaching California, but as we get into Friday night, another little tiny patch of 20 knot winds off of Cape Mendocino. Not really doing a whole lot. Look at this. What's this? A 38 millibar high in the Gulf of Alaska. Just locking things down. Brick wall. Any storms that would develop would get shunted north up into Alaska if they were to make it this far. 1038 millibars on Sunday. But not ridging towards California. Just sort of just locked out here in the middle of nowhere, doing nothing, maybe generating more windswell even into Hawaii into late Sunday, a week out. So no real wind swell yet, but no start of a fall pattern either. All right, let's take a look long term. What's going on with the MJO and El Nino? So as usual, first we'll start examining the presence of the active phase of the MJO. Typically, so this time of year, well, actually right now we're seeing pretty strong easterly winds over the eastern Pacific. This from the TAO buoy array, series of buoys strung across the equator. There's the equator right there. East Pacific here, West Pacific here, New Guinea there. These buoys are used for monitoring the formation of El Nino, but it can also give us a good idea just sort of what's going on in general in the tropics. East winds, as you see, the long arrows, over the East Pacific, but then dying once you get to the dateline. There's the dateline, and almost pretty calm in the western Pacific in what we call the Kelvin wave generation area, from 135 east to 170 west, 5 degrees north and south of the equator. When the active phase of the MJO is in control here, winds tend to die, so this sort of suggests that winds are dying and that the active phase is in control in the West Pacific. And if those dying winds, or sometimes the winds actually turn westerly, if that happens over a long enough period of time, that can take warm water in this area, push it to the east, and that's in the form of a Kelvin wave, a ball of water that travels under the equator, makes it the whole way to Ecuador, and then erupts at the surface, causing a pool of warm water here. And if a couple of those happen relatively quickly in a row, that's how you can get El Nino. Anyway, looking at anomalies, differences from normal for this time of year, we see winds, yeah, kind of dead neutral. The arrows aren't doing anything one way or the other, but look at here. We see westerly tendencies for sure in the Kelvin wave generation area, suggestive of the active phase of the MJO. If that's true, let's dig a little deeper. Looking at wind anomalies for the entire equatorial Pacific, there's South America, there's New Guinea, Australia, equator right there. The area we're looking for, Kelvin wave generation area, 170 west right there. Build a little box right along here to 135 east, 5 degrees north and south. The red and oranges and the arrows indicate westerly anomalies. This is 850 millibar wind anomalies. That's up about 4,700 feet, but a good proxy for what's going on down at the surface. And that was as of August 13th. You can kind of go through here. You see consistent westerly anomalies in the western Gulf of Alaska, in the western Pacific, suggestive of the active phase of the MJO. And that's what we want, because the active phase of the MJO not only can create Kelvin waves, but it also can impart energy to the jet stream and help fuel the storm track. You notice we look at the jet stream charts, and if the jet stream is doing the right thing and has energy, it tends to form troughs, and troughs, of course, tend to form storms, and storms create surf. So what's the forecast? Well, this is a nifty little chart. It looks at wind anomalies, zonal wind anomalies, for the whole planet. All we really care about, though, is the Kelvin wave generation area. So here's the date line running right down the middle of the chart. There we go. See 180? Okay. And the Kelvin wave generation area, basically between these two tick marks, and you can just go down the chart. This is what's happened past history, July. And what do we see here? A big red blob. That means a big area of westerly anomalies that filled the Kelvin wave generation area from about August 6th to about August 16th or 17th, so 10 days, like a small mini westerly wind burst. That's good news. That might help impart some energy to the jet stream, but it would have done it by now, and it hasn't really done a whole lot, certainly not in the southern hemi. Maybe this is what helped develop that one little tiny gale in the Gulf of Alaska, but that still wasn't a whole lot. Then we look at the forecast, we see blues, which means easterly anomalies. So whatever was happening, the exact opposite is supposed to happen for the next week. So a pattern probably not supportive of storm or gale development. So what's going to happen with the MJO? Well, let's look at some other data. Outgoing long-wave radiation. Basically, this is how much sunlight is going to be reflected off the ocean's surface. Blues suggest less sunlight reflectivity. That means clouds. That means the active phase of the MJO. So some weak version of the active phase of the MJO here in the West Pacific. There's New Guinea. There's South America. Equator runs right along there. And looking for the next 2 weeks, per this model, the statistic model suggests the active phase is pretty much steady state in the West Pacific. That's not bad. And the dynamic model, the GEFS model, suggests the same thing. Maybe not quite as strong as the statistic model 2 weeks out, but still, that's better than the inactive phase. So some weak hope for maybe some imparting some energy to the jet stream per these models. Phase diagram charts. So these charts tell us where the active phase of the MJO is. So assume this circle is the North Pole. You're looking down on the North Pole, and the active phase travels from west to east, from the Indian Ocean over the maritime continent, through the West Pacific, under the United States, across the Atlantic, across North Africa, and back to the Indian Ocean. And the active phase of the MJO goes round and round. It's about, spends 3 or 4 weeks in the Atlantic. It takes who knows how long to make it the whole way around the planet. But when it does, so basically 3 to 4 weeks in the Pacific, then 3 to 4 weeks of the inactive phase in the Pacific, followed by 3 to 4 weeks of the active phase. But it could be up to 6 weeks. Anyway, the heavy dot is where the active phase is right now. So let's say basically over Bali, but if it's inside this circle, it's very weak. The further outside here, the stronger it is. So a very weak active phase, basically over the Bali area. The forecast per the green line is for it to basically stay there for the next 2 weeks, and then maybe slowly ease off to the east into the West Pacific 2 weeks out. That per the ECMF model. The GEFS model says basically the same thing, but not making as much eastward progress, and both say it's supposed to remain very weak. So pretty good consistency between all the models so far. Let's dig a little deeper. The upper level model here suggests areas, so the greens are areas favorable for precipitation. One could interpret that to mean the active phase of the MJO. Here's the equator here, South America here, New Guinea there. So you see green here, West Pacific, active phase of the MJO, slowly fading out, working its way off to the east and moving over Central America and gone, say about the middle of September, while the inactive phase, the yellows, yellow mean not favorable for precipitation, the inactive phase, moving into the West Pacific, the end of August, and it too making its trek across the Pacific into late, about the 28th of September, with when at that time a yet even weaker active phase is to follow. Now, point to note here, the active phase, or when you have El Nino developing, what happens is the MJO basically disappears completely or gets very weak, but atmospherically, the El Nino basically makes it feel like you're in a perpetual active state of the MJO. And what this model is sort of saying right now is the MJO is supposed to be weaker and weaker and weaker as we move into fall. That likely is because El Nino is supposed to be developing. So that brings us to the short-term CFS view here, okay? What are we looking at? Well, this is, again, whole planet on one chart. There's the date line running up through the middle of the chart. Kelvin wave generation area between these two tick marks, so going down. The reds are westerly anomalies, meaning the active phase of the MJO, okay? And we see this is what just happened, a westerly wind burst right in the core of the Kelvin wave generation area. Now you notice here we are, and each of these tick marks here is weak. So for the next week, things are supposed to sort of back off in the Kelvin wave generation area. See this red dotted line? Oh, you can't see it up. Here we go. Equatorial Rossby wave. We won't get into the details of all that, but basically there's this wave that's going from east to west in the Kelvin wave generation area. It's supposed to sort of stomp on westerly winds for a week, week and a half. But then look what's coming right behind that. Westerly winds building and getting strong again like a week and a half from now and nonstop into at least September. Also notice here the purple line, low pass filter, suggesting some sort of low pressure bias building in this area here, right over the Kelvin wave generation area. So let's go look at the long-term model. So here we go, the long-term CFS model. This goes out, 3 months? Okay, now it's different. Past performance is down here on the bottom. Again, Kelvin wave generation area between these two tick marks. You can see our recent westerly wind burst that just happened, or called a mini westerly wind burst. Then here's where we start. We'll overlay the MJO. You see the solid contour is the active phase of the MJO, fading out, inactive phase building. But what you should note here is that, see the yellows? Westerly winds, westerly wind or westerly anomalies still in the core of the Kelvin wave generation area, even though the inactive phase of the MJO is supposed to be in play. Those westerly anomalies are supposed to continue nonstop into the end of the model run here, like November 16th or something. Notice the MJO very weak too, all but fading. That's what we were talking about. When El Nino gets going, the MJO starts dissipating, but westerly wind anomalies, and it's pretty strong here, suggesting maybe another westerly wind burst or a mini westerly wind burst. Two little spots here in like September, again in October, and this sort of smells of El Nino. Let's overlay the low pass filter. Here you go. It's in black this time. Notice. So this is the area, sort of consider it a low pressure bias. The dotted lines are a high pressure bias, okay, and California is like 120 west, so this is California, this is the Pacific Ocean, there's your date line. The far west Pacific would be over here. What does this mean? Low pressure bias filling the entire North Pacific at this point in time right now, and only supposed to get more established over the next 3 months. What that means is, yeah, maybe everything isn't coupled and El Nino isn't fully in control, but the longer this low pressure bias stays in place over the Pacific, the greater the odds of El Nino's signature starting to become manifest in both the atmosphere and the ocean. That is, the ocean needs to make a turn, and the atmosphere needs to make a turn too. They both need to line up and be sort of in favor for El Nino. The longer this low-pressure bias holds there, the greater the odds that that will in fact happen. So this is very good news, and we've been watching this. Also notice the high-pressure bias over California, which sort of blocks things out in terms of precipitation, dies and is gone by September 25th or so, opening the storm door for California as we get into the fall. So we've talked about the atmosphere and the active phase of the MJO and the possible building of El Nino, but the ocean has to be sort of in favor of all that too. It can't just one of them do it. Both the ocean and the atmosphere have to be aligned. So we look at ocean temperatures specifically. So this is the data from the TAO buoy array, East Pacific here, West Pacific here. These little lines here are the anchors on the TAO buoys strung across the equator. The X's are the sensors on those anchor lines. With that and a little bit of modeling, you can sort of get a sense of what the sea surface temperature profile is at depth. What we see is warm water, 30 degrees Celsius in the far West Pacific. The 28-degree isotherm line stuck at 160 west. It had built the whole way over to maybe 137, something like that, maybe a month ago, when we had a strong, large Kelvin wave pushing from west to east. And then the 24-degree isotherm, it had actually retracted back to 120. Now it's starting to move back to, what is that, about 112 west, something like that. But still not pushing into Ecuador like it was earlier. Okay, so that all sounds kind of interesting, but let's look at anomalies, differences from normal for this time of year. And what do we see? Slightly warmer, 1 degree above normal temperatures in the shallow waters of the upper East Pacific. But what is this? Lo and behold, another Kelvin wave building. Not particularly huge, not particularly strong. 3-degree anomalies per this model, but filling a pretty good area. You can see it right here, coming in from off the maritime continent, building with 3 degrees at its core down at 170 west, so just this side of the date line. This is good news. And here's another model of the same data, we think a little bit more accurate, suggesting the Kelvin wave actually is stronger. 1, 2, 3, 4 contours. 1, 2, 3, 4. 3.5 degrees above normal and broader in coverage. Downwelling Kelvin wave. So Kelvin wave, of course, is warm water. It falls to depth, then traverses the Pacific, and then erupts off the East Pacific, forming a warm water slick. This is the remnants of Kelvin wave number 1 from a strong active phase westerly wind burst that occurred back in February. It's done its main thing, and it's fading now. Last little warm anomalies between, let's say, south of California and out to maybe Hawaii, something like that, on the equator. But still, good news. Second Kelvin wave building. It'll take 2 to 3 months to make it over to the East Pacific, but at least there's one in flight. Sea level anomaly data. So this is from the JASON-2 satellite. Basically, it's a satellite, beams down the ocean surface, tells you how high the ocean is different from normal. That is, it strips out all the waves, you can strip out all the waves, all the wind waves, the tide even, and get a sense of what's going on. What we see here is the ocean is higher than normal. This is the date line. Here's the equator right here. Centered over, there's New Guinea there, okay, Philippines here. So the entire West Pacific, just on the equator, and that's all that matters, 5 degrees north and south of the equator, is higher than normal. What that means is warm water is at depth. Warm water, of course, expands. Cold water contracts. So this suggests a large bubble of warm water is underneath the West Pacific, seeping off to the east, making it to about 110 west. So really what this is the fading remnants of Kelvin wave number 1. This is the beginning of Kelvin wave number 2 building, and it's expected, this bubble is expected to migrate the whole way across the Pacific and then erupt. There's the Galapagos, Ecuador, in this region about 3 months from now. So what's that, August to September, October, November-ish time frame, sort of in here, and that would be the typical time that El Nino really gets going, and especially when you see warm water building up off this area. So at least there's some hope that that might happen. So here we go. This is upper ocean heat anomalies, upper 300 meters of the ocean. This was La Nina back September, October, November. This is the East Pacific here, West Pacific here. First tiny little Kelvin wave, we're not even labeling, occurred back in January of this year. It hardly made it across. The yellows, oranges are warmer than normal temperatures. Upwelling phase of the Kelvin wave cycle. Now here you go. Starting in February, remember, big westerly wind burst occurred in the West Pacific, made a Kelvin wave. You can see the warm water slowly making it the whole way to across the East Pacific, erupting at the ocean surface. It's discharging now. Notice, blues, blues. So we'll call it the upwelling phase of the Kelvin wave cycle. But what is this here? Here's our next Kelvin wave building on the dateline from westerly winds that have occurred and are occurring. And also, as we talked about last week, and it doesn't have, these westerly winds don't have to completely be in the West Pacific too. They can be over the maritime continent, basically off the chart. We think that's where the bulk of this warm water came from. It bled through the maritime continent into the West Pacific, and then another westerly wind burst on top of that, just helping to give it some momentum to push east. But it's got 3 months to go to make it the whole way to the far East Pacific. All right, so what's going on at the ocean surface? We've talked about the MJO, we've talked about winds, we've talked about the atmosphere, talked about ocean depth, what's happening to water temperatures down at depth, but it's really the surface that really matters. And the good news is things are happening. Warm water, warmer than average, from Ecuador the whole way out to a point almost south of California. Now, this has been kind of fluky. It just developed in the past week, let's say. Okay, and there's still these couple little pockets of cool water. So this is not some robust, massive, El Nino thing going on, but at least it's the water temperatures, surface water temperatures are biased towards El Nino in the Nino 1.2 region. That's basically in this area out to about 110 or 110 west, 120 west. The main El Nino monitoring region is 5 degrees north, 5 degrees south from 120 west. That's due south of California, out to almost the dateline. You can see, yeah, pretty good area of warming, not super solid. We got a little bit of pockets of cooling there. The actual temperature trend in the Nino 1.2 region, that area right there by the Galapagos in Ecuador, yeah, slowly working its way upwards as of today, though still minus 0.2 of a degree or 0.02 of a degree below normal. So not even positive, but that doesn't matter as much as the Nino 3.4 area, the area, south of California on out to the dateline. And the trend there is pretty much static right now. It's plus 0.02 of a degree above, or 0.2 of a degree above normal. 0.234 of a degree above normal. That's not some sort of robust El Nino by any stretch of the imagination. So what this suggests is, if there is an right now, basically temperatures are normal, give or take a little bit. But the trend appears to be towards warming. Now, is that going to make real El Nino status? It has to be at 0.5 for about the equivalent of 9 months before you declare El Nino. We're nowhere close to that yet. The trend the past 7 days, you can look at it here. These pockets of red and brown suggest warming, but there's also a couple of pockets of cooling interspersed in there. So kind of a mixed bag here, but the sense is, yeah, generally things are trying to warm, but it's just doing it in fits and starts. Basically, if El Nino is organizing, it's an extremely weak El Nino. I mean, big El Ninos, you can see it in February, March, April. It's like a wall coming at you. This is not the case. This is like a dribble of water coming down the gutter in your road at you instead of a gully washer flood. But at least it's not La Nina. If anything, we're setting up for, let's call it a normal winter, maybe biased slightly warm. Here's the overview picture. Yeah, you see warming. These oranges and yellows suggest warming, but you also have this pocket of cooling here. And there's not some big pronounced triangle here like you'd see of warm water like you'd see if there was a real El Nino. It's just kind of this mixed muddy pattern that hasn't quite got itself together. Here's the remnants of La Nina cool water hanging down here. So still kind of a mixed bag and just not, but the reality is, would you expect an El Nino to be happening 2 years after a super El Nino? Was that 2014, 2015 sort of time frame? Probably not. So just to have neutral is probably the best you can hope for. That said, here's the forecast from the Nino 3 for the Nino 3.4 region for this from the CFS version 2 model. Now the interesting part is somewhere back here warming was supposed to be starting, but you see it's just flatlining here at about 0.2 degrees, and the model keeps hinting of some major increase, but we're looking at the models, we don't see some massive Kelvin wave coming, and it just seems like this big building wall of warm water that's supposed to be setting up on the equator probably isn't going to happen unless some miracle occurs. Anyway, the model continues to suggest temperatures building to 1.25 degrees above normal in October and up to 1.5 degrees above normal as we get into the fall and into January, and then slowly fading from there. That seems highly optimistic at this point in time. If we got a 0.75 degree El Nino out of this, that'd probably be the most we're going to get given what we see at this point in time. So we're not getting too super excited about some big El Nino coming. There just isn't enough latent heat energy in the atmosphere or the ocean after having a major El Nino so recently to get another decent El Nino out of it. But it certainly appears that a La Nina is dead, and that as we get into fall and winter, we could expect a normal winter, maybe something a little bit better than normal. Anyway, to wrap things up for right now, yeah, we have small southern hemi swell fading out in California, maybe dribbles for the next day or two, and that's about it. Small little gale formed in the Gulf of Alaska. Tiny swell to result for Hawaii, but probably not anything for California. The best California has to offer right now, literally, there's been nothing in the southern hemi, so no southern hemi swell is on the chart for the next week. Maybe wind swell for north and central California, even that pretty meager. Relative to Hawaii, wind swell certainly, and for the Big Island, southeast shores, swell from Hurricane Lane. Keep your eyes on what Lane's official track is. At this point in time, Hawaii looks like things are probably going to be okay. Yeah, easterly trades, some rain and some wind, but no direct hurricane impacts whatsoever, and no real swell, just wind swell for exposed east-facing shores of the Hawaiian Islands. Anyway, we're waiting for some form of El Nino to develop, more Kelvin waves, more westerly wind bursts. At least La Nina does not appear to be in the forecast for this winter, so that's good news. So that's it for this week. We'll do it again next week, same time, same channel. Thanks for watching.